This is work and power example 3. It goes along with example 2. We have Sharita in the previous example. Remember, she was really tired after doing her physics. She went very slowly up the stairs and she took 10 seconds to go from the bottom to the top. The next evening, she's in a big time rush to watch her favorite TV show, so she runs up the stairs in only 3 seconds. They want to know on what night does she do more work. Well, for both of those, she does the same amount of work. The work doesn't depend on how much time it takes her to go from the bottom of the bottom step all the way up to the top. The thing that is going to be different is the amount of power that she uses in order to go from the bottom to the top step, and it's dependent upon the time. So for the first night, we know that her work was 2,500 joules, and the time that it took her was 10 seconds, so she was pretty slow. Power is pretty simple to do. It's just work divided by time. So big W we said was work. We're going to divide that by time. And when we plug our numbers in, we get 2,500 joules divided by our 10 seconds. And power then is equal to 250 watts. So the unit for power is a watt. And we'll talk a little bit more about watts when we get into electricity. On the second night, same amount of work again, but this time the time is much shorter. So if we use our power is equal to work divided by time, it'd be 2,500 joules divided by 3 seconds, and she has to have a lot more power in order to do this one. She's got to have 830 watts.